Alright, so let's continue with number 11. Using the following information, write a conclusion if possible. So, where did my cursor go? Okay, there it is. Sorry. It says, if you are in 10th grade, then you are eligible to get a driving permit. So, you are in 10th grade is P. You are eligible to get a driving permit is Q. Then it says, Jennifer has a driving permit. We talk about driving permits in Q. So it seems like this should be law of detachment. However, law of detachment mentioned the pattern of P and Q, P, and then the conclusion is a statement that refers back to Q. So if I were to be following, excuse me, sorry, the law of detachment, right now, what is currently given to me is not following that pattern. The pattern is supposed to be P, Q, P. Right now, the pattern is P, Q, Q. So since it's not following the correct pattern, we have to say no conclusion. Now let's look at number 12. If you are in 10th grade, then you are eligible to get a driving permit. That's the same statement. So that P is you are in 10th grade. You are eligible to get a driving permit is Q. Then it says Jennifer is in 10th grade. We talked about 10th grade in P. So far it is following the law of detachment. P, Q, P. So now we can conclude, based on the law of detachment, that Jennifer is eligible to get a driving permit. So you notice the difference in 11 and 12. We can't assume anything. It has to follow a specific pattern in order to write a valid conclusion. And we always want our conclusions to be valid. And in order to be valid, it has to be based off of a law that has already been proven. And the law of detachment is one of those laws that has been proven. So the pattern is a must. Number 13 says, A equals 8 is an example of which property? So take out your property sheet. It's on pink paper this year. But take out your property sheet and look for an example of two numbers or two identical things on both sides of the equal sign. You're looking for that mirror image, also known as the reflection. So that means 13 is an example of the reflexive property. Number 14, if A is equal to B and B is equal to C, then we can conclude that A equals C is an example of which property. So on that statement, you notice the middle piece is the same. The middle piece contains B, so B repeats itself right in the middle. And I stress that if the middle repeats, you're supposed to delete the repeat. And when you delete the repeat, the two outside pieces can be smushed together. So anytime the middle repeats and you delete the repeat, that is the transitive property. Number 15, if x equals 3 and y plus x is 7, then y plus 3 is 7. When you compare those last two equations, you should realize that x was replaced with 3. So since x is being replaced in this example, then you are using substitution, because substitution is when you replace one piece of information with another piece of information. So substitution. All right, number 16 says conjecture. If x is an integer, then negative x is negative. Which statement below is correct? Conjecture is maybe just a fancy word for statement or conclusion, or and so we're just trying to prove if this statement is false or true if you look at our answer choices. So answer choice A says the conjecture is false because a counterexample would be x is equal to negative 5. So in other words, if I were to take this expression negative x and in place of it put x is negative 5, what would I get? So when you have a double negative situation, that becomes positive, right? So what the conjecture is saying is if x is an integer is a positive or a negative whole number, then anytime you put a positive or a negative number in place of x, you will always get a negative answer. Well, I just showed you that when you put negative 5 in place of x, you get a positive answer. So I'm going to have to say it's choice A. It's false. And my counter is if I put in negative 5, then I get a positive answer. Let me read that again. I'm trying to do it slower this time. What this statement is telling you is that no matter what type of number you put in, what type of whole number, your result will always be negative. That's what it's saying. Whenever you plug in a number, positive or negative, the result is always a negative. And so I proved it wrong by plugging in negative 5. And then when I plugged in negative 5, as you see on the right, I got a positive answer back. So that's why it's a false conjecture. All right, 17. We get into our formal proofs, ladies and gents. And they have some reasons blank, they have some statements blank, but we have to fill them in. Given Q is between P and R is between Q and S, as well as the measure of PR is equal to the measure of QS, our job is to prove that PQ is equal to RS. So let's get started. They gave us that Q is between P and R. So that was our first given. They actually gave us 3 pieces of information, but we only write one at a time as of right now. So then it tells us that in statement 2 that PQ plus QR equals PR. So PR, if you look at the figure, represents a whole. PQ represents part of that whole. QR represents another part of that whole. So we got an example of part plus part equals whole, so that means it's segment addition postulate. Then statement 3 says R is between Q and S. That was another one of our given pieces of information. And then reason 4 says they want us to use segment addition partial again with that new information about R being between. So that means the whole would be QS, and QR is still part of this whole. RS is another part. So we would say QR plus RS equals QS. That's a Q. And then statement 5 says the measure of PR equals the measure of QS. That was given as well above. So they were very generous in this problem. They gave us 3 pieces of information, and you should be grateful whenever they give you anything. Take it and run with it. So to go from statement 5 to statement 6, sorry, you should notice that, sorry, let me move on. The same thing has been added to both sides of the equation. So that means we use the addition property. And then they're taking statement 6 and subtracting QR from both sides. So that's the subtraction property in statement 7. Now, when you subtract QR on both sides, they will both disappear, and all you'll be left with is PQ equals RS. It should be here in the first place because, again, the last statement will always be the proof statement. I apologize. Statement or reason for number 6 is not addition. And to understand it, you gotta pay attention to a few things. In statement 5, we said that we were given PR is equal to QS. We have to go back and tie this statement to statement 2, where we said PQ plus QR is PR. So what we did in statement 5 was replace PQ plus QR for RS. PR, sorry. Let me repeat that. Hold on just a second. So in this statement 2, we have PQ plus QR. In statement 5, we said PR was equal to QS. So we are replacing PR with PQ QR on the left side right here. So since we are replacing, we're using substitution. Sorry, my handwriting is horrible. I know. So, and then on the right side, we have to go back and tie it to what we wrote on statement 4 about QR and RS. And then again, we replaced it on the right. So again, it's substitution, not addition. Number 18, another proof, and it's angle based. Segment AB is perpendicular to segment BC. Angle 1 and angle 3 are complementary. Prove that angle 2 is congruent to angle 3. So the first reason, no matter what, is given. The second one wants us to use the definition of perpendicular. If you look at your property sheet, the definition of perpendicular says that when two lines that intersect and form a 90-degree angle. The two lines in this picture are AB and BC. So those two lines form an angle when they meet, and it's a 90-degree angle, so we can say angle ABC is a right angle. Angle ABC is a right angle. So then, because it's a right angle, in statement 3, we know the measure is 90 degrees, because that's the definition of a right angle. Then in statement 4, it tells us the measure of angle ABC is equal to the measure of angle 1 and measure of angle 2. Well, that's the angle addition postulate. When you have two small angles making up one large angle, it's always angle addition. And then you notice that ABC was replaced with 90 in statement 4, so that's why it's the substitution property. Then it tells us that angle 1 and angle 2 are complementary. Well, that's the definition of complementary, when two angles add up to 90. Statement 7, they want us to use the other given information. So that means we're going to say angle 1 and angle 3 are complementary. And then statement 8 is our proof statement that the angle 2 is congruent with angle 3, but the reason is because two angles are complementary to the same angle, then the two angles are congruent. So I believe it's called the congruent complements theorem. I don't have my pink sheet with me, but you should. The congruent complements theorem, I believe, is what it's called. Just write it verbatim from your pink property sheet, just the title, and you're good. Number 19 would like for us to write the symbol for each one of these statements. So it's good practice that you know the symbols for these. Conditional statement is P, then Q, if P, then Q. For converse, it's if Q, then P. For inverse, it's not P, then not Q, or think of it as opposite. the contrapositive is not Q, then not P. And number 20, our last one. Determine the validity of the statement below. If false, provide a counterexample. So the statement says, if you trip and fall, then you didn't tie your shoe. When it says determine validity, that means, is this statement true or false? So this is a false statement because, and when you say because, you're countering. So you're just providing another example. Just because you tripped doesn't mean you didn't tie your shoe. You could have tripped because you are clumsy and you missed a step. So that's a counter example. So you tripped and fell because you missed a step. And there's a counter. Had nothing to do with your shoes. You just are a very clumsy person. So when you're determining validity, in order to be true, it has to be true all the time. And again, just because I fell, trip and fell, I may not have anything to do with my shoes. I could just be a very clumsy person and miss a step. Well, this concludes your tutorial for this review. Good luck on your test.